All right. Hello. This is 7-2 day 3. All right, and this is kind of the last day of this radical craziness. All right, these radicals. Now, we did variables one day. We really focused on just variables, and then yesterday in the video we focused on just numerical basis. Today we're combining numbers and variable basis. So same type of problems. All right, just combining the two ideas. All right, so I got about 6 or 7 problems we're going to work through together. All right, so let's set up the first one. The cubed root of 10x to the 5th times the cubed root of 2x to the 3rd. Now, we both have cube roots, so let's combine them. So 10 times 2 gives me 20. X to the 5th, x to the 3rd gives me x to the 8th. Now, some of you like to simplify first. If that's the case, cool. Then combine. Now, again, remember, we treat numbers and variables different. So if we're breaking down the 20, I have 5 and 4, 2 and 2. I'm looking for 3 of a kind. There's no 3 of a kinds. So I can't mess with the 20. All right, and then 8, well, how many groups of 3 are in 8? There's 2, and there's 2 left over. So x squared. So x squared times the cube root of 20x squared. And that's all I can do there. All right, let's try another one. The cubed root of 7, the 7th root of 27x to the 5th, all to the 4th power. All right, now again, it's important that we start doing these on our own. So it might be a good idea to pause the video now, give this problem a try, and then go back and check my work. So do so if you wish right now. If not, here we go. All right, so I'm going to take the 4 to everything on the inside. All right, so the 7th root of 27 to the 4th, x to the 20th, because 5 times 4. So the 4 has to go to both terms. Now, 27 can be written as what? 3 to the 3rd, right? Okay, now, you might again try to tackle this a different way. 3 to the 3rd to the 4th, x to the 20th. Because if you multiply 27 to the 4th power, you're going to get some big crazy number that you're going to have to break down and find 7 of a kind. Not very ideal. So that's just how I thought of it. And I got 3 to the 12th power times x to the 20th. All right? Now think about it. How many groups of 7 do I have in 12? Well, 1. And I have 3 to the 5th on the inside still, right? Kind of like what we do with the variables. And I have 20 x's, so there's 2 groups of 7 in there, and I'm left with 6 over. Now 3 to the 5th, let's put that in our calculators, because it doesn't give us a huge number. So 243 looks prettier. Now, if for some reason, and this is the 7th root, sorry, I forgot to write. For some reason, if we get like 3 to the 20th power, I don't expect you to put that in your calculator and write some large number. You can leave it, but 243 isn't a large number. So I expect that to be written. All right, next one. The cubed root of 81, x to the 5th, y to the 6th, z to the 7th. All right, well, 81. I'm going to break this one down just to show you a little something different. So 81 we know is 9 and 9. 3 and 3, 3 and 3, and I'm looking for 3 of a kind. Alright, so I got my 3, they're going to come out. And there's 1 3 left inside. Alright, whoever's left alone stays home. I have 5 x's, so I have 1 pair of 3, there's 2 left over. I have 2 pairs here, because 2 groups of 3 come out. None left in the middle, and z, 2 groups also come out, and there's 1 left. All right, so just taking all our knowledge and putting it into one problem. Okay, a few more just to get us used to this. And then we'll be ready to review and take our quiz. All right, so let's go 4x squared times the 4th root of 243 x to the 13th, y to the 16th. All right, so really we don't need to do anything with this yet, but just write it outside. All right, 243, 81 and 3, 81 is 9 and 9, 3 and 3, 3 and 3. I'm looking for 4 of a kind. So I got 4 there and I got 1 left alone. So 1 comes out, 1's left inside. I got 13 X's, so how many 4s, groups of 4 are in there? Well, that's 4, 8, 12. There's 3 groups with 1 left over. And there's 4 groups of 4 and 16, so those all come out. Now combine your like terms on the outside here. 4 times 3 is 12. X squared times x to the third is x to the fifth. Alright. And then y to the fourth. And 3x is left inside. Alright. How's that looking? We good? Alright. Number 5. 2 times the cubed root of x to the third. Let me write that a little neater. All over the cubed root of 2x squared times the cubed root of 32x to the 7th. Alright, now up top, I'm going to simplify this right off the bat because the cubed root of x cubed is just 2x. Alright, and then over here I'm going to combine these because they're both cube roots. So 32 times 2 is 64. X squared times x to the 7th is x to the 9th. Now, 64, if you go to break it down, alright, we got, let's go 8 and 8, 4 and 2, 4 and 2, 2 and 2, 2 and 2. So I got 3 of a kind, 3 of a kind. So 2 2's come out. 2 and 2 gives me 4 on the outside. And x to the 9th, there's 3 groups. And I have 2x on the top. Well, that worked out nice. Don't have to rationalize because that was a perfect cube there. So 2 divided by 4 is 1/2. I have 1x on top, 3 on the bottom. So 3 wins by 2. So 1 over 2x squared. All right. 2 more, then I'm done. So 6 and 7. All right, number 6. Let's go the cubed root of 125 x to the 9th all over y squared. Now, whenever you have a big fraction under a whole root, I like to split it up. So cubed root 125 x to the 9th all over the cubed root of y squared. Right, so the cubed root of 125, well, that's just 5. And the cubed root of x to the 9th, that's 3 pairs of 3. And then down here, I'm left with this. So now we're forced into a situation where we have to rationalize. Now I have a cubed root, so I need 3 y's for a perfect cube. So I'm missing 1 y. So the cubed root of y. So when I multiply straight across, I'm going to go down here. 5x cubed to the cubed root of y all over, now I have a perfect cube of just y. So these are all ideas and concepts that we've learned. We're just putting them together now in larger problems. All right, the similar progression we've been experiencing all year. All right, the cubed root of 27x to the 7th plus x cubed times the square root of x to the 4th. Now these are the sneaky guys, all right, when it's adding and subtracting. So the cubed root of 27 we know is 3. How many groups of 3 can I take out of x to the 7th? That's 2, and I'm left with 1. All right, oops, sorry, I'm going to make this the cubed root. Okay, please don't forget to add the 3, my mistake. So how many groups of 3 are in x to the 4th? Well, there's 1, and I have x to the 3rd on the outside, so 1 comes out, and I'm left with the cubed root of x. So 3x squared times the cubed root of x plus x to the 4th times the cubed root of x. All right, now, can I combine these? All right, no, I cannot. All right, because one has an x squared and one has x to the 4th. Again, if this was x squared, then I could go ahead and combine them. All right, now I'm going to send you home with one. So I want you to complete this one for homework. So once you end this video, so I want you to complete this one for homework as soon as you end this video. So 3 times the cube root of 8x to the 6th y squared z to the 4th minus 2x times the cubed root of 27 x to the 3rd y squared z to the 4th. All right, so come to class tomorrow with this problem done. I'll check it as part of your notes. Enjoy. See you tomorrow.